All right. Well, welcome. We have, and I'll be glad when the three other people are here. And so, but what they're going to miss, they'll be okay. They can make up what they're going to miss. All right. So first of all, you have your book. Let me go ahead and read that a little bit. And we actually do start out with some things you've done before, but we do them a little differently and we do them a little faster. And I had to make that decision many, many years ago when I started this, and because you had, as the 10th grade is when you took Chemistry 1. And it would be, if I just started with stuff you've never done before, that would be okay, but I don't think when you went to college, you wouldn't feel comfortable. They're going to start with the same stuff that your book does. So even this book, an AP book, actually starts with the stuff from first year chemistry. It just goes faster. And for example, maybe 3 chapters of first year chemistry is found in 1 chapter here. You get that? And here's the bad news about college. They'll take 3 of these chapters before they give you a test. So think about that. 2 or 3 of the first year chapters would be equal to 1 of those. And in college, they'll probably do 3 of those before they give you a test. So the better you know this stuff, the stuff you had in 10th grade, yes, we want to go over it, but a little bit faster, but you want to master it. You want to say to yourself, you'll never have to worry about me doing that again. You'll never have to worry about me knowing how to do factor label. Never. You'll never have to worry about me not knowing how to write formulas when we get to formulas. Now, some of you liked formulas when you did the first time, and some of you didn't, but you're going to master it. That's the key. And so when you get there, you'll get more comfortable, and if they do 3 chapters in a row, you'll say, I'm okay. I'm okay with that. And I think that's why people come back and say that they did well, because they had that. I can't just skip. I can't. And that's my opinion, okay? That's my opinion. Okay, so anyway, so one of the things we're going to do, we're going to do the elements again, but instead of doing 20 every 3 days, we're going to do 30 every 2 days. So see, we go a little faster, don't we? In my opinion, there's no reason that a second-year chemistry student wouldn't know all the elements. You get that? So maybe, how many of those do you think you forgot from 10th grade?
All of them.
Okay, then we're doing the right thing. So what we'll do is, let's go ahead, and I'm going to spend just a little bit of time on this, and I don't want to give you a quiz tomorrow, but I will give it probably on Monday. And again, I'm really nice about this because I'm going to only count them half a point apiece when you first take them. So when you do the first 120 elements, that'd be 60 points, okay? And then I'll give you a final, and that'll be like a point apiece, and maybe I'll do 50 of them, any 50 that I want. Got that? I might even throw in some extra credit, like maybe anything past 115. Maybe I'll do that. Maybe I'll do the last 5. It'll be bonus or something like that, okay? All right, so what we're going to do is take a look. If you have your packet, the packet I gave you yesterday, did I give you this packet? Okay, let's go ahead and get that out. And again, I'm not going to spend a lot of time because I actually have something else I think you'll have fun doing today. And it's going to be like a little scavenger hunt. Okay, and so let's take a look at elements 1 through 30. Now, it's up to you how you want to study these. If you want to make index cards, or you just say, like write them on a piece of paper. But you have to be able to know what elements and the symbol and how to spell it. Okay, so let's take a look. First one's hydrogen. And what I like to say is it spelled the way it's pronounced? Yeah, except it has a Y in it, doesn't it? Okay, so let's move on. Hydrogen. Helium. How many L's in helium?
1.
Really only be 1. It'd be helium, right? So that's my little memory trick. Helium only has 1. Okay, how about lithium? Is that spelled the way it's pronounced?
Yeah.
Okay, what's the next one?
Beryllium.
Okay, and that's always a hard one because the word berry has 2 R's, but not this one, right? That's only B-E-R-Y, then what? Look at it. B-E-R-Y. L-L-I-U-M. Okay, so again, if you want to make little notes to yourself, you want to get a piece of paper out, it's up to you. All right, what's B?
Boron.
Is that spelled the way it's pronounced? All right, you should be all right on that. How about carbon? We always say carbon, don't we? But it's carbon. All right, next.
Nitrogen.
Is that spelled the way it's pronounced?
Yeah.
Okay, how about oxygen?
Yeah.
There's a Y in there, right? O-X-Y? All right, how about, this is the one you tend to miss in 10th grade. How do you spell fluorine?
U-O.
All right, yeah, F-F fluorine, isn't it? All right, next.
Uh,
Neon, that's pretty easy. How about sodium? It's Na, isn't it?
yeah.
So the Latin word natrum, because it was discovered so long ago, it had a name a long time ago, natrum, and that's what they used to call it. But it's called sodium. All right, how about the next one?
A little Latin.
What do you think? Magnesium, 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 or magnesium?
Magnesium.
Listen, how many S's then?
One. No, yeah, one.
I'm trying to help you. I'm trying to say what are the trick things that might make you stumble a little bit. Okay. All right. What's the next one? Okay. Now, aluminum. I will say that in the United States, it's weird. In the United States, we have always said aluminum, but even other English-speaking countries and other countries, they say aluminium. So if you go to England, they're going to say aluminium. If you
Like that.
it's weird, but in the United States, we actually say aluminum. And aluminium has an extra I in it, doesn't it?
Yeah.
So I like you to say aluminum because, as far as I know, you're going to study in the United States. But don't worry about it. If you go to England, you can say aluminium. It won't take that long. Next. What's the next one?
Silicone.
But how many L's? See, it almost should be pronounced silicone, okay? By the way, silicon, I should say. Do anybody know what silicone is? It's a rubbery material, isn't it? And it's actually a compound. This is an element, and it's one of the most abundant elements on the planet. Sand is silicon dioxide. Computer chips, we're Silicon Valley. Get that?
Oh.
So they use silicon it's a semiconductor. It's a semi-metal. It's a semiconductor. Okay, next. This is a hard one because it's what?
Phosphorus.
All right, PHOS, PHOR. Usually people get that far. Then what? Oh, just US, not OUS, all right?
I think that
If
was.
there's an English word, like an adjective, it'd be OUS. Just US.
US more us, and then this is more us. Like phosphorus.
If you want to have a memory check, you say, well, phosphorus is for us.
Oh.
All right, next one, sulfur. When I was in high school, we actually spelled it SULPHUR, but nobody does that anymore. So sulfur now is
Is
SULFUR.
that the correct way?
What now?
Is the old way that you spell it the correct way?
No, nobody does that anymore. So, okay, so sulfur, SULFUR. Okay, now chlorine. There's no U there. There's no U there. Chlorine. And then argon. That's spelled the way it's pronounced. And then potassium has two S's. That's why you said potassium.
And it's a K.
And the K, and that used to be calcium. The Latin word is kalium. That's where that came from. All right, calcium is Ca. Calcium. All right, now here's where it gets a little harder, 21 to 30. Scandium, titanium, vanadium, chromium. Now this one, look at 25 and 12. For whatever reason, I don't know why I didn't make a memory check. It's not that hard. When I say magnesium, see the G? Manganese, manganese. Mn is a symbol for manganese, manganese. Okay, iron is Fe. Ferrum is the Latin word for that. That was discovered a long time ago. Cobalt, Co. Nickel, and it's not spelled like pickle. Pickle's Le and nickel is El.
Oh.
So make a little note of that. And then we have copper is Cu. I know you wanted Co to be copper, but it's not. Cu is copper. And zinc is Zn, and it's Zinc. Now, I know that what I'd like you to do then, on Monday, we'll do 1 through 30, and then we'll study 31 to 60. So I want to ask you to do this. Say, there's no reason why a second-year chemistry student shouldn't know the elements, all of them. All right? All right, you okay with that? All right. So let's go ahead and I want to show you another thing. I think I put this in the packet. Just want to show you what's in here. This one is a, wait, that's not the same one, is it? No. Okay, this is one that I had to change two names because internationally, cesium is spelled a little differently. Do you see that? See how cesium is spelled there? And in the United States, we spell it SESIUM. So same thing with aluminum. I had to rewrite that one. So this was actually from the IUPAC. Now, IUPAC, if you become a chemist or you have anything to do with chemistry, you'll hear about this international, so the International Union of Pure and Applied Chemists. So when they say UPAC name, I'm trying to think of this over here, that means that's a group of people that all over the world, and they make decisions, like who gets to name that element? What are we going to call that, you know? For a while, we had elements like 110 to 118. They did not have the same name around the world, but they only meet about every 5 years. And so for a while, like Russia had lots of their own names for those elements because they said, we did it, we found that element first, we discovered it. And then California said, no, you didn't. University of California, no, you didn't do that. And so then eventually a group of chemists around the world, they have to make a decision who gets to name that element. And so these are the ones that are settled. This is what they have to be. Okay, the next thing I gave you was, just in case you were looking for an alphabetical listing of the elements, there they are. Okay, and then the next page, this is kind of interesting. These, if you were interested, densities. Now, these densities are in the common ones I use in physics, grams per cubic centimeter. But when you get over here, notice that they went to this. See, it says kilograms per cubic meter. Now, you could sit there and do factor label, and we'll practice that again, or you could just do this. If you take this number here in kilograms per cubic meter and divide it by 1,000, you'll get 0.00120 grams per cubic centimeter. So if you're wondering why air seemed to be more dense than water, no, that's in kilograms per cubic meter. If you change it, it'll be 0.00120 grams per, see that? Okay, so I thought, next, this is one that has the symbols on it. And so if you want to just practice, I look at a symbol, do I know what that is? Like, do I know what that one? Hey, look right here, ready? Go, what's that one?
Titanium.
This one.
Iron.
This one.
Manganese.
This one.
Magnesium.
Okay, this one. This one.
Nickel.
Okay, this one.
Spin.
Okay, this one.
Silicon.
Silicon. Okay, all right. So anyway, that's what that's for, is to practice, do I know my names from the symbols? And in here, you don't have to use this, you don't have to, but I made I kind of completed these. These are old names, they won't be used anymore, but if you wanted to just look at the name and say, do I know the symbol? And that's another thing to practice with that. This will come in later. We know that these are the alkali metals, alkaline earth, transition metals. We did that. We'll do that again. So that's just what that is. Let's go to the next one. This one, here's a good word for you. What's etymology? Did you have that in humanities? Have you heard that word in humanities class? Etymology is the root of words. Where did they come from? Like, why do you use that word? Like, I thought one of the most interesting one, look at cobalt. Why would they name an element cobalt? What's it mean? Goblin, what the heck? Okay, so why did somebody, whatever the story is behind cobalt, has something to do with ghost. Okay, so anyway, I thought I'd throw that in there just for your interest. You don't have to, I'm not going to test you on it or anything like that. But there are some interesting things in here. Some of these I know you could figure out, like uranium. What do you think that's named for?
The planet.
Yeah.
Let's go.
Matter of fact, a lot of the Greek gods are down here. Anyway, okay. And so then also the last thing I put on here, this one, you'll hear about this guy's name again, but at one time people used their own symbols for elements. And this person had these symbols, somebody else had these symbols, and we'll read an article later about alchemist. Have you ever heard of alchemist? Did you do that in humanities? Okay, so for over 1,000 years, there were people who were trying to change matter, and one of their goals was to try to change matter into gold. And some people did it because they thought it was divine. They thought it was godly to do that. And some people did it because they thought they could make money. That is the humans. Isn't that the human? So anyway, we'll read an article about alchemists, and they each had their own little symbols, and they didn't want you to know. They had a little cookbook, you know, how to do this stuff, and they didn't really. Some were in codes, and they had a code for the element lead. And so if you didn't know their code, you wouldn't know how they do their secret recipe on how to change one kind of matter to another. But Berzelius, he came in and he eventually gave symbols for elements, and that's how we get that. Okay, and the last one, I had this is just fun for me to do. I asked hydrogen ion if he was sure he had lost some of his electrons. He said what? Yes, I'm positive. Okay, anyway, a little nerd, okay? Anyway, we will do that again. We'll do the ion thing again, make sure you know what ions are. Okay, it says here, hey, when you look in a mirror, do you say, I'm so copper tellurium-like? Cute, okay, down here. Scientists say they were able to finally make a compound between lithium and argon. Wow, a compound with a noble gas. What do you think? I have trouble believing this. What's that?
Oh.
What would the formula be? Okay.
Oh.
Okay, true or false? If this question is true, write the formula of the compound. If it's false, write false, meaning it cannot be formed. A compound formed with one atom of fluorine, one atom of aluminum, and one atom of selenium. What do you think? If it can be formed, write the formula. If it can't, write false, meaning it can't be formed.
I know it's false. I feel like I'm missing something.
Oh. See, if you write false, you're saying it can't. You're saying it can't be formed. But if you say it can be formed, then
I get it.
all right. Now, what we're going to do the rest of the period. This is something that is a little different than first year. First year chemistry, almost always the material is out there for you. You might have to go get a beaker or something, but eventually, I would like you guys, when you do your labs, is that you go get your equipment. And you clean it, you put it back, and that kind of stuff there. So what we'll do is, I do want you to know lab equipment, so we're going to do this again. We're going to do it a little differently. You're going to form teams of about, let's see, how many I have? 3, let's see, 1, 2, 3, 4. Okay, I'm going to have two teams of 2 and 1 team of 3. Okay, so you can have that table, that table, that table, that table. So what you're going to do is you're going to go around the room, and you're going to go find these things and put them on your table. Now, when you get there, you got to go together. You have to go together. So, if you guys, when you go together, wait, who's my team of 3?
Me.
Okay, all right. Now, when you go together, you have to go together because you don't want Owen to be the only person to know where the funnels are. So you have to go together, and then when you get there, you put little check marks saying you found it, and then you tell yourself, what's this called again? Oh, that's a volumetric flask. Can you get it?
Yeah.
All right, so what I'm going to do is I have some equipment back in this other room. I'll have to get that out, but all the other equipment is out here somewhere. You got that? What now?
Wait.
Yeah, let's find all of it. All right, so here's what I do. So you're going to have a scavenger hunt. You're going to leave it out. I'll tell you what, do me a favor. Don't use the first 2 tables. Because I'm going to use those for demonstrations in another class today. But here, pick one of these up. Get your team going. And when you think you found it, leave it on the desk. And by the way, I'm going to turn the camera off because they're going to go search for all these things.